this example, we're going to work through an example to see how to do an analysis of variance, ANOVA test in Excel. And as our research question, we'll take whether parental education is linked to reading scores in 15-year-olds. More specifically, we're going to look at three groups: students both of whose parents have bachelor's degrees, one of whose parents does, or neither parent does. And we want to know if the mean reading scores are the same for all three groups. So here is some small data set that I got by taking some of our PISA data from our website, and we're going to use that to investigate the question. So column A represents reading scores of 15 students, both of whose parents had bachelor's degrees. Column B, just one of their parents had bachelor's degrees, and column C, neither of the parents had bachelor's degrees. And before we do the ANOVA, let's just make box plots of these to try to answer the question visually. So we select the data, we insert, we look for recommended charts, and we'll look at all charts and choose box and whiskers. And here we see box plots of the three sets of data. So do they look the same? No. Do they all have the same mean? It doesn't look like it. But is the difference statistically significant? Maybe it's just random variation. That's what hypothesis testing is all about. So let's now do a formal hypothesis test. So what's a null hypothesis here? Well, a null hypothesis is that the three groups have the same mean. So it would look like use of both equals, so the mean for both is the same as the mean for where only one parent has a bachelor's degree, is the same as the mean when neither parent has a bachelor's degree. An alternative hypothesis is that the three groups do not all have the same mean reading scores. Okay, great. So now how do we do this in Excel? Let's go back here. So the way to do it in Excel is to go to Data, Data Analysis, and we're waiting for that to open. What is going on here? There we go. ANOVA single factor. And where's the data? Well, we've got it highlighted here, so I selected the data. And we do have, it is grouped by columns. Each column is one of the three groups we're interested in. We do have labels in the first row. So we hit OK. And there's our p-value, 0.55. Now notice, by the way, that when both parents had bachelor's degree, the average was 549. Average reading score was 549 if both parents had bachelor's degrees. If neither had bachelor's degrees, it was 522. So that looks like quite a difference. But this p-value is telling us that, as far as this data is concerned at least, it's not statistically significant. It wouldn't be surprising to happen by random chance. So let's go back here, do step 2. We just found the p-value equals, is it 0.5 what? 0.55 to 2 decimal places. So p-value equals 0.55. Well, that's not small at all. That's not below 0.05. So decision, do not reject a null hypothesis. Conclusion, we do not have evidence that the mean reading scores for the three groups of students, the three populations of students, are not all the same. The data we collected is consistent with all three groups having the same mean reading score when you looked at the whole population. So explanation, if the three groups all have the same mean reading scores, there would be a 0.55 probability of getting sample means as far from each other as we did. In other words, even though in our samples the mean reading scores were different, if the population mean reading scores were the same, it wouldn't be surprising to get a sample means this far apart from each other. And in addition, this problem is a good example of why we say that there's no evidence rather than saying, hey, the three groups do have the same mean. The data we have here didn't supply the evidence. In large part, that's because the sample size was so small. If you go back and use all of a piece of data, you'll get a tiny, tiny p-value, and you'll see that in fact there is a great deal of evidence that the three groups don't have the same mean reading scores. But this particular sample, small sample size, didn't show it. So that's how you do it in Excel, and that's another example of how to state your conclusion and your explanation for hypothesis testing.